Hey everybody, this is Larry. This is day 24 probably of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this poem. I was like, what am I? Oh, that's right. I resetted my Chrome browser thing so that, I don't know, I was, anyway, I'll use, yeah. So maybe all my cookie settings are finally gone and stuff. But yeah, how's everyone doing? Hope everyone's doing okay on this weekend. Today, I did a park run. I don't know if people are familiar with this, but apparently it's a very British thing. So if I have any British fans, let me know in the comments, or British haters even. I don't know, anyone British who happens to be watching it. Let me know in the comments. But I did one in Brooklyn. Apparently, like I didn't know it was a British, or I didn't know it was so majority British because like 90% of the people are British. Anyway, I bring it up because I had my first park run today. I ran my PB on a 5K, so that was kind of nice because I've not been training for it at all, right? And I didn't even rest that much for it or anything like that. So it was a nice surprise on my way to still on my marathon training. I slept all day. Everything is very beat up and tired. I mean, a little bit, my I feel like I'm a little bit fresh, but yeah, my muscles are definitely a little bit sore. But yeah, today we have a medium problem, so let's get to it. And then, because after this, I'm going to do the virtual, the contest, the weekly contest. Definitely, if you're a contest doer, let me know in the comments and stay tuned for those videos. But yeah. Let's take a look. We have 1493 longest subarray of 1's after deleting one element. Given a binary array nums, you should delete one element from it. Fine. Given the size of the longest non-empty subarray containing only 1's in the resulting array. Let me say that again because I didn't read it. It's one of those things where sometimes you say it aloud, but you're not processing. That doesn't count, right? Return the size of the largest non-empty subarray containing only 1's in the resulting array. Return 0 if there's no such array. No such subarray. I don't know why I said that in a weird connotation. But alright. I mean, I feel like I think for problems like this, especially if you're, I think this is pretty doable. But for problems like this, especially if you're a little bit newer to Leetcode and stuff, definitely the idea is that, well, first, just think about simulation, right? And then what happens? Well, if you simulate, then you remove, in a brute force way, let's say, you remove one digit, one number, and it's going to shift everything behind it, right? And if you make, it's going to take linear time, you have linear number of possibilities, then that's going to be too long. The key thing about this one is just sliding window. And the sliding window solution is based off the fact that deleting one is just the same as ignoring one, right? Or having 1 0, or at most 1 0. There is an edge case that I see that you. Yeah, I'm just rereading again to make sure, but there is an edge case where it's all 1's, and I think my interpretation is that you have to delete one out of it. Okay. Actually, yeah, it's an example with three, so okay. So it's not a trick. I mean, it is still a trick case, but they show you, so that's fine. But the sliding window, I guess, aspect comes from the fact that, this idea of invariance, where as you I think another way to think about sliding window, and I've been thinking this a lot because this is 5,000 videos in or something like that, maybe not that much, but getting there or close or whatever. Just thinking about the idea of contribution for these problems, and the idea that I have for contribution is just that I think the technique and ideas are mostly the same, but it's just one little tweak to how I think about it, which is that for every number, as we slide, if you will, what is the answer, the contribution, if this was the last element in the array, right? And here, and the idea behind sliding window then is that you take advantage of the previous solution, right? So let's say maybe the previous is here, and then this is the left, this is the right, right? And then you move the right to here, and then now you have to update this. Well, if you update this, then what's the best that you can go to the left? The best that you can go to the left is the previous 0, right? It is. I mean, I'm just going to skip a little bit and just move this here, right? Instead of animating it or whatever. But as a result, right? And then the idea here behind the sliding window, the way that I try to think about all the time, is that the invariant is that in a way, future things, like for example this 0, you ask the same question, right? You ask the same question, all right, how far, if this is the last the last element of a subarray, how far can we go to the left? Well, the idea here with this slide is that everything to the left of this is not possible, in the sense that you could treat them as not existing, right? Because I mean, in this one, it makes more sense. I'm explaining it in a way that is more general, but I'm using it as this one. So for this one, it may sound a little bit too much in the sense that it's not necessary, right? Like, Larry, we know where the last 0 is. You just have to keep track, etc., right? But I'm just trying to get this idea across on sliding windows where, okay, well, if this is 0 and this is the thing, everything to the left of the left window, I mean, this is what we're currently here, but let's say in the future, and that's what I'm trying to say is that given here, we move this marker on the left marker, if you will, to here, because we know that everything to the left can no longer be a possible answer, right? Meaning that you cannot go that far to the left because, well, here, you have to remove 2 zeros, for example, etc., right? So that's kind of the general idea that I want to get across. Maybe, you know, today I'll keep it a little bit brief, because for this one, like I said, it, you know, but yeah, and then we'll just structure the sliding window, right? Oh, why do I write that? I think I saw best to 0, 0, and I just wrote 0. But anyway, guys, yeah, and then, yeah, I mean, as I said, there are different ways of writing this, because if you kind of look at it that way, then now it's just about the last zeros or something like that, or 2 zeros ago, if you want to say it. So you can write something that's really specific for this problem, but I want to write it in a general way. That's why, right? So then here, if nums, right, is equal to 0, and then maybe we just go, you know, zeros is equal to 0. That's the number of zeros inside. 0 increment by 1, right? So while 0 is greater than 1, so that means that we have 2. Then we have to shift left, right? So we increment left, but only after we subtract it out if it's a 0. And then now, yeah, we have to remove it. So best is just go to max best right minus left plus 1. Keep in mind the thing here is that we always oh, actually I don't, I lied. Actually, I write it this way: minus plus 1 to be inclusive of the right bounds and left bounds, but minus 1 because we have to remove one element, and that's basically the idea. Did my buttons move? Because I think my buttons move to the top again. I have to set this up because I reset my cookies, I suppose. Like I said, I don't know where things are anymore. No, I like it here. Oh, there we go. Yeah. Looks okay. Let's go quick submit. And there you go. Apparently a while loop isn't fast enough anymore, but I don't know. I'm fine with that. Yeah, because you know why? Because I know the complexity. And this is linear time, constant space. Can't really do better than that. That is in fact the lower bound. You can make some micro optimizations, but I personally don't care that much about it. So yeah, that's it. That's all I have with this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.